Semua dengar Semua boleh dengar dengan clear, dengan jelas. Right. Dora, are you okay, Dora? Dora Itang, kamu ada dua login sekali handphone dekat ni kan? Oh mungkin laptop tak boleh nak cakap kan? Okay. Alright, see you again in this class. As I always remind everybody in my class, we are now in week 16. If I'm not mistaken, when we refer to the academic calendar, all right, so we are now in week 16. Okay, sebenarnya kita ada 15 week all together in one semester. Kita ada 15 minggu in one semester, including semester break. But for this semester, a little bit change, ada a little bit special case. You were given, I think, 5 day, 5 day for the cuti bertenang, during the banjir season hari tu. All right. So we have this week is the final one. This week is the last one in this semester. We are now in week 16. Kita sekarang week 16, and then we have supposed to be today is our class, and also next Thursday. So we will finish our lecture on today. Okay, hari ini kita akan habiskan lecture. So we just have 2 more topics, subtopic in this chapter. All right, in linkage mechanism chapter, we have done the first one, introduction of the basic kinematic for linkage mechanism, and also all the terminology used, and also we defined the mobility from Gruber equation, and also we define the Grashof law, right? The Grashof law for four bar mechanisms, right? And also we have done the second part of this topic of this chapter. That is the position analysis, all right? And today we're going to continue. We're going to finish this chapter by looking at chapter 3.3. Okay, the third part of the chapter, that is the velocity analysis as well as the acceleration analysis. These two are basically the optional chapters. Basically, it is similar to what we have learned before. The most important part in this chapter is that the position analysis. Once we have done the position analysis, then we can do velocity as well as acceleration analysis. So velocity and acceleration analysis is quite similar to position analysis. We have done, right? We have fully understand the concept of the position analysis using. When we look at the position analysis, we have we can use different types, different methods. We have different methods to solve or to do the position analysis. Where I told you we can do. For me, the easiest is we can do using circuit diagram methods. Using circuit diagram method as well as trigonometry method. We can combine the trigonometry method and trigonometry methods by applying the trigonometric laws. For example, sine laws as well as cosine law to find the length, and also we can also find the angles. If not, we can refer to the circuit diagram, where we have the circuit diagram for 4-bar mechanism as well as for the glass-sided crane mechanism. That is for position analysis. Right. For this one, for velocity and also for acceleration, it is similar to this, to position analysis. We can also refer to the the diagram. So we can also refer to the circuit diagram, right? And based on that circuit diagrams, we can just apply the formulation. All right, we can solve the equation to find the velocity as well as the acceleration. So sama juga kita boleh gunakan kaedah yang sama, the same method using circuit diagram, and based on that circuit diagram, daripada circuit diagram itu kita boleh gunakan, we can apply all the formulation ataupun equation to find the velocity dan juga to find the acceleration. Konsep yang sama, hampir sama. Alright, before that we have to look at the difference between velocity as well as acceleration. Apakah perbezaan? But the method is quite the same. Method hampir similar. There is a graphical method as well as analytical method. Okay, kalau analytical graphical method, it is straightforward. We can just simply draw, if you know how to draw it, and then if we don't want to draw it, we can just solve it using analytical method that I will show you later on. All right, now let's look at the first one. That is the velocity analysis. So this is the velocity analysis. So basically we define the velocity first. So velocity, basically we have linear velocity. So what is linear velocity? Linear velocity is that, all right, is measured, all right, it is speed, all right, laju, halaju, right, kelajuan, right, that is speed that is measured, how fast an object move, sejauh apa tu, selaju mana, okay, selaju mana sesuatu objek bergerak, alright, that is the speed that measured, alright, ataupun it is basically distance, okay, how far the distance is, alright, sejauh mana jarak, the distance, jarak. Assalamualaikum, nampak ke ni? Tiba-tiba pula tak nampak. Can you hear me, guys? Sorry, I tak ni, sorry Supposedly I share, you tak ni pula. Assalamualaikum, senyap je ni? Are you okay? Class, Pak Khan?
Okay.
So hear me, okay? Right. Okay. So this is what I said just now. The linear velocity is that a speed. It is a speed. Okay, a speed is a measure how fast an object move. Sejauh mana ataupun selaju mana sesuatu objek itu, sesuatu benda itu bergerak. Ataupun kita boleh, we can look at from the distance that is covered in the time unit. Okay, sejauh mana ataupun basically it is the unit, the common unit is meter per second, right? 1 meter, 1 second. Let's say that is how fast, that is the speed, right? That is the speed that's measured. 1 meter, 1 saat, ataupun 0.5 meter in 1 second. Right, so that is the speed. That is the linear velocity. And velocity also includes the scalar speed, that is magnitude and also direction. Magnitude, berapakah nilainya, dan juga directions, whether it is in clockwise directions, counterclockwise directions. So, kita boleh, we can put a symbol as VB. For example, this case, for example, this is the link number 2, for example. This is number A. A is a frame. This is number 2. This is number 3, right? All right, and then when we want to find the velocity of point B, okay, point B, ataupun the link number 2. Link number 2 and point B the same velocity, velocity yang sama. So we can find it at point B. Let's say point B. Let's say the input link rotate. The input link rotate counterclockwise direction. Counterclockwise direction. Then we have to find the velocity of point B. Ataupun we can find the velocity of the link number 2. Link number 2, the velocity is the same as point B. Right, and also when, let's say this is connected, these links are connected to each other. Yang mana link 2 dan link 3 connected. When the first link ataupun when the input link, so this is the input link, rotate, okay, rotate or move counterclockwise direction, then link number 3 will also move counterclockwise direction mengikut the input link. And then we can find the velocity point C as well. Dan kita juga boleh mencari point C. Right. So the common unit, it could be meter per second, it could be feet per minute, it could be mile per hour, it could be kilometer per hour. So basically kita gunakan meter per second ataupun I think that's a millimeter per second, millimeter per second. Right, and then if you want to draw the vectors for this one, so basically the linear velocity of a point is perpendicular to the radial arm of the point. So this is the radial arm of the point, so it should be perpendicular 90 darjah. Right, the vectors, all right, if you want to draw it, kalian do case, if you want to draw the free body diagram, then the linear velocity should be perpendicular to the arm. And also the sense of direction must be agreed with the rotation of them. Jadi the directions, the arrow here should be samalah dengan rotations of the arm. Let's say I said the arms, the input link rotate counterclockwise directions. Therefore, the directions of the vectors also should be the same as the rotations of the arm. Right now, we know that the velocity is the change in distance. Okay, change in distance, so we can put it as a ds. Kan kita buat pembezaan, okay? ds over dt. dt is a change in times. Okay, that velocity is ds over dt, and the change in distance over the change in time. All right, so basically we have that is the linear velocity, and the second one is the angular velocity. Okay, angular velocity is basically is a measure of how fast an arm rotates. So this is the angular velocity. Angular velocity is basically is the change in angle over the change on time. So d theta over dt, the change in times. Theta is the angles, change in angles over change in time, change in time period. All right, so we can just put it so d theta dot. All right, angular velocity include the scalar angular speed magnitude as well as rotation. So the common unit for angular velocity is revolution per minute, RPM. Kita biasa jumpa, right? Kita biasa jumpa RPM, also radian per second, alright, ataupun degree per second. So basically it's all the same, sama je, dan that is only the units. Kalau revolution, 1 putaran per minute. Kalau radians, 1 putaran is equal to 2 pi radians, 2 pi radians. Alright, and VB and VC, and as I said just now, should be the same. The directions should be the same as the angular velocity. When angular velocity omega rotates in counterclockwise direction, and also the directions of the velocity for point B as well as for point C is the same. Should be the same as the angular velocity. All right. For example, in this case is CV. This is normal common counterclockwise and also clockwise direction. Itu the direction yang ada for the angular velocity. Whether it is clockwise direction, whether it is counterclockwise direction. Right. So we know that this is the main relations. When we know the velocity, we can find when we know angular velocity omega, right? Omega is given. Let's say given. Then we can find velocity. Velocity is equal to r omega. So this is the relation between the velocity as well as the angular velocity, the linear velocity and also the angular velocity. kena ingat, you have to remember this equation, alright, untuk mencari nilai velocity. Ataupun when we know the angular velocity, we can find the velocity. Alright, sama juga, when we know the velocity, then we can also find the angular velocity. Right. For this case, omega should be in radian per second. If needs changing to linear velocity, if you want to find the linear velocity in terms of meter per second, right, then we have to change it into radian per second first for the for the what? Angular velocity. Now, look at the example. The velocity of point C is 10 meter per second. Okay, determine the velocity of point B if the link is rotating clockwise about pivot A, right? So this is clockwise direction. Okay, clockwise direction. Then we know that, so we know the velocity of point C, right? We know the velocity of point C here. When the point C move, right, move, and also when this link move, then we can find the velocity. So we can find the velocity. But for this case, we are given the velocity. The velocity is equal to 10 meters per second. So we can find omega here. So angular velocity based on V is equal to R omega. So omega is equal to VC divided by R. RC is 38 centimeter. We can just put it into meter so that we can get it is in radian per second. Right? So we know that the angular velocity for these two should be the same. Right? Sebab the links are connected each other about the pivot. So when this link rotate using the same angular velocity, then we can find the velocity of B using this equation. VB is equal to RB omega. Omega the same. We have found it here. Right, we got it here, 26.32 radian per second. And this one, the radius, the length of the AB is equal to 0.25 meter. So you got in meter per second, right, in meter per second. Right. If you want to put it in millimeter per second, just convert it into millimeter per second. So radian per second. The unit for omega should be in radian per second. Radian is dimensionless, that the unit bagi dengan radian per second. So meter multiplied by radians, it is meter bagi per divided by ataupun over per seconds. All right, so this is how you find the velocity or the angular velocity and also the linear velocity for this case. All right, boleh? Fat, okay, Fat, boleh faham ke? Asaf Fansuri, Alistair, Daniel, ada ke Daniel ni? Haris Najmi, Haziq Musa, tak menyahut. Ada ke tak ada ni?
Ada.
Ada Dr. Izul ada.
Ada.
Izul, ada Izul.
Ada Dr.
Alhamdulillah. Dah makan dah?
Belum ya Dr.
Nak makan apa tu?
Nak makan roti canai.
Makan rencana. Buat sendiri ke?
Tak beli.
Cuba buat sendiri. Boleh buat tak?
Dah pernah buat lah, tak sedap.
Tak sedap tak jadi Saya pun I used to buat benda ni before. Saya buat juga dululah. Macam dulu masa duduk kat luar negara kan, memang Allah Akbar, memang teringin sangat nak makan roti canai kan. Cubalah buat. Cuba buat sekali. Tengok ala kat YouTube kan boleh buat kan. Cumanya buat memang tak jadi. Memang tak jadi. Tak sedap. Bukannya tak sedap. Memang tak jadi. So I was very upset that time. Memang tak tahu mungkin tepung dia tak sama dengan tepung gandum kita di Malaysia kan. Tapi ialah mungkin tak sama. Cuma apa ni dia punya ingredients, dia punya bukan ukuran apa dia. Dia punya apa ni panggil apa sukatan semua all the same dah kan, kita dah ikut je YouTube kan, YouTube ke. In fact memang tak jadi roti canai, memang kena ada skill jugalah kena ada skill yang bertahun-tahun baru jadi buat roti canai itu kan. Okay, tak apa. Ala kulli hal, you can just beli je lah satu tu, apa ni, RM1 je kan, satu canai. Ataupun you can just buy the what? Yang dah ready made kan? Ready made dah siap dekat shopping complex. Just goreng je.
Betul tak ada breakfast ke?
Dah, saya dah breakfast, saya tawar tadi, saya singgah tadi dekat beli kat luar tadi, singgah, sempat. Tak apa, beli. Okay, yang lain, Zulhelmi dah bangun dah, makan dah. So macam mana kalau belajar perut lapar, supposed to have your initial breakfast ataupun you
Tak
beli
nampak tu, biasa macam ni.
biasa je minum
Hmm.
air 3 in 1 dulu ke Milo ke baca sikit kan. Okay. Kalau tidak mungkin nanti you apa ni tambah lagi duduk rumah lagi lah. Okay, bosan kan. Sufi Aiman dah hilang. Tidur balik. Nur Ali Zurmi.
Ya, saya.
Sihat ke?
Sihat, Alhamdulillah.
Suara ceria. Dah makan dah?
Dah makan dah.
Okey. Masak ke? Yang perempuan ni boleh masak kat rumah kan?
Tak, roti bakar je.
This is the time untuk apa panggil apa? Untuk belajar masak. Alright. This is the time. You all duduk rumah sewa, belajarlah masak. Okay, esok pun nak kena masak kan? Nurhana ni duduk rumah sama ke dengan Nur Ellie?
Tak, saya duduk dengan Izzati.
Oh, dengan Zati. Tapi di hostel kan duduk sini kan, Melaka kan?
Betul.
Betul lah sebab you ada IDP kena duduk Melaka lah. Alright, okay, so clear yang ini, this is just macam pengenalan lah, introduction, supaya kita faham. Okay, sebelum ni kita belajar the point, the analysis kan, the position analysis. Bila point C berubah, move, right? So we need to find the new position, right? The new position of point C, right? For this case, bila link tu bergerak, then we need to find the halaju. Right? We need to find the halaju. For this case, okay, using the equation, velocity is equal to R omega, right? So that we can find the velocity. Okay, for this case, given that the initial velocity point C itu, kan, when the link move at, for example, point C, bila kita point C, we can also put in your mind that point C itu adalah the link AC itu. Link AC dan point C having the same velocity yang sama lah. So untuk memudahkan kita nak buat analisis, we can just put it as a point C. When point C move dengan certain halaju, iaitu certain speed, iaitu 10 meter per second, alright, then what is the angular velocity? So angular velocity come from this equation. Alright, so based on this equation, we have 26.32 radian per second. That is the angular velocity. And bear in mind that the angular velocity for this case is the same for both links. Angular velocity sama for both links, link AC and also AB. Using the same equation, VB, RB, omega. Omega the same, RB is the distance, the length of the link AB, then we can find the velocity point B. Right? Okay, so that is how you solve these problems. Then look at the methods. We can also solve the problems using the velocity graphical method. Macam kita ada buat position analysis, kita ada buat method kan. Seperti mana yang saya explained earlier today, we have different type of methods to do the analysis. It is also the same for velocity analysis. Right. Now, okay, look at this example. Look at this example. And when the link, this is the input link. So let's say the input link rotate, right, clockwise direction. There will be a velocity at point B here. Point B is the velocity for the link AB. So we just put it in point B. So the arrow here Alright, the vectors here should be 90 degree. Kan kita dah define tadi mesti 90 degree. It should be perpendicular, kan, perpendicular to the what? To the link. Alright, to the link. Jadi dia mesti 90 darjah to the link. So that is the velocity point B. Right? And then you can also find the other vectors. Okay, guna lukis vectors. Okay, let's say kita yang point kat sini, kita point of interest kita, we want to find the velocity at point C. The velocity point C could be the velocity of the link here. Link ini ataupun link yang ini. So link, let's say this is second link, this is third link, and this is fourth link. So you're going to find the velocity point fourth link. The fourth link adalah velocity point C. Now, so based on this, okay, we can draw the vectors, other vector at point here. Okay, now, kenapa ada banyak vectors ni? Banyak anak panah ni, garisan ni. So now, this one, okay, kalau you tengok sini, this is 90 degree, isn't it? 90 darjah. So 90 degree, okay, from link 3. Link 3 adalah from B. So this will be velocity C relative to B. Okay, so this one is C relative to B. Okay, okay, ni pun sama juga sebab arah lain, different direction only. Okay, going up and going down. Alright, kita lukis dahulu. Okay, and this one is velocity point C relative to D. Kita tengok 90 degree from D, isn't it? 90 degree from D. This one also velocity apa ni? C from D. This one is C from D. Okay, so kita dah ada all the vectors. So now untuk lukis, right? This is graphical method. If you want to draw this, if you want to draw this, then you just draw it. Okay, macam mana cara nak draw it? Dia kata A and D are pivot on ground frame. So this one A and D, they're fixed on the ground. Dia berpusing, dia berputar, but it is just fixed on the ground. Okay, the velocity start from here. Okay, from here, sini dia kata, from here, dekat dua ni lah. So either one. So let's say it's point B sini. As for point A is the velocity start from point A, all right. And then so we have the velocity. Kita dah ada satu bagi vectors the velocity point B macam ini. Then kita kena lukis exactly like this. Okay, we can draw exactly like this. So this is VB. This is VB is given. VB is given. Mesti diberi. Kalau tak ada VB, then kita tak boleh cari. Kita mesti ada satu velocity, a reference. We call it as a reference velocity. For this case, the reference velocity is VB. Right. So VB is the reference. And then we have all these vectors. Okay, jadi macam mana kita nak buat? The next one is we have to join all the vectors. For this case, kita ada VCB. So this is VCB kan? Atas dan bawah. This is VCB. I think I need to erase this, clear this, everything, so that you can look at it clearly. You can see this clearly. So this is VCB. So kita lukis VCB. And then this one is VCD. This is VCD. Right, nampak VCD. So kita punya drawing, right, is similar to this one. Alright, and then dia kata get the intersections of the unknown. So this is the intersections of the unknown, right? So this one VCB, this one VCD. So this is the intersections of the unknown. So that is how you draw it, right? This is VCB, this is VCD. So this is the direction, and then how to find nilai kan, the value of the velocity at this point. The value of the velocity of this point is by measuring the length and the angle. So you have the angle, all the angles, then you can just find it from the drawing, right? From the drawing that you do using CAD software, for example, right? That is how you draw the vectors, the vectors polygon from the graphical velocity analysis. Okay, now look at the example, this one. Okay, it is 10 centimeter crank So this is 10 centimeter. Okay, revolved at 100 RPM counterclockwise. So kita ada omega sama dengan 100 RPM. So basically this is, selalu kita gunakan N kan, speed. Okay, ataupun then we have to convert it into omega, alright, kita convert it into omega in term of radian per second. Okay, jadi kita kena apa? Kali dengan 2 pi, so tak apa, kita tengok kemudian. And then clockwise, the connecting rod is 150. The offset is 7.5. The crank angles here is 30 degree. I think crank angles I show you, this is 30. This is 30 degree. So this is 30 degree. Find the velocity of the pistons. You need to find the velocity of the piston here. Okay, V4. Okay, velocity of the piston. Then you have to draw it. Okay, lukis kan should be like this. All right, using the before that you have to find the position. Okay, you have to do the position analysis using graphical method untuk dapatkan the position, right? The position 46.66. That is the positions of the velocity of the slider crank here. Right, when we have the angle here, when we have the angle 30 degree, all right, so this is 30 degree, we have the length here, this is 150 length. Right, dalam keadaan begini, so what is the distance of this one? Right, how to do it? Then you can draw it using CAD software, or you can just solve it using apa? Using circuit diagram. Circuit diagram, that is equation from the circuit diagram that we learned last week. Then we can we can put it here. All right. Okay, so okay, now we know that, okay, this is the RPM. Okay, this is the link, the omega here. Given that omega is equal to 100 RPM, then we can find velocity. Velocity is equal to radius. The radius is 10 kali dengan omega. Omega should be in radian per second. Right, you have to convert it into radian per second, then you get, for this case, is equal to 0.15 meter per second. All right, dapat kan? Dapat velocity point B. So because this is counterclockwise direction, then the unit, the direction should be that way. Should be going to that way. All right, and then you know, you have to draw the. Remember that the vectors. So this is should be perpendicular, right? Perpendicular to the link. Kan, this is should be perpendicular to the link. Mesti 90 darjah to the link. This is, okay, let's say this is point A, this is point B, this is point C. So this one adalah C, we see respect to B. We see respect to B, it should be certain. Then this one is we see. This is we see. Point C ni lah. Point C ni bergerak. Point C is the sliding mechanism, right? So you have to draw this one. So look, you have all the vectors. Okay, now you have all. Alamak, hilang. You have all the vectors. Saya delete kan supaya you nampak. So this is. Okay, jadi kamu dah ada all the vectors, you sambung lah. Sambungkan vektor tersebut. So the vector should be this one, satu, these vectors. Okay, second one, the third one. So then you have to join all the vectors here. So join all the vectors, nampak kan? So this is VCB. This one VC. So just sambungkan supaya they close the loop. Supaya close the polygon lah. We got this is called the polygon vector. Loopnya hanyalah this one, this one, this one. This one either this one, for this case, either this one, okay, this one, atas ke bawah. So this will be. So it should be like this, and you just measure the length. Ukur saja length, atau you just measure the length sebab kita gunakan panggil apa graphical method sebab we know we can just put it in the drawing lukisan and using all the correct dimensions kan kita ada this one is 1.15 the length is 115 is the velocity of B point B adalah 1.05 just ukur je lah ukur panjang 1.05 let's say cm pendek sangat kan you scale up sikit lah you besarkan sikit okay and then angle we can find the angle here okay semua you boleh cari kat angles all this angle okay the angles all these things draw it okay and based on this okay this should be 90 degree kita dah ada kan kita dah ada ni 30 darjah so you boleh tengok lukis ni berapa apa ni angle ni berapa ni this one it should be and then based on that you can find this is 108 so lukis correctly using CAD software using all this angle then you can just simply measure the length you just measure the length of the vectors for this case VC adalah 0.82 meter per second VC is going to that way is minus going to this way is positive kalau kita tengok ada punya ni kan going to this way is positive going to that way is negative so based on this VC is going to that way going to the left is negative so that's why the unit here magnitude is 0.82 the length of the of VC okay, panjang VC yang you lukis vektor tu adalah 0.82 meter per second that is the magnitude and tengok the directions going to the left adalah minus okay. Ataupun you can just boleh buat macam ni jugalah gunakan these vectors to find the answers. So for this case, you can find it. The answer is 0.96. This length is 0.996 for the velocity point C and C relative to B. Ataupun you boleh gunakan loop equation. Okay, loop equation. Yang ini saya I'm not very good in this one. Okay, you can look at if you want to. You can try this if you want to. Right, boleh cuba juga. Alright, using this loop equation. I don't think this is the same question from the tak sama soalan yang sama. This is contoh lah. Contoh when we have the loop like this, then we can just and we have all the length of the vectors, then we can find the remaining length ataupun the unknowns from the so if you look at this all these are tu semua the distance ataupun panjang length and then you differentiate with respect to time you dapat velocity you can find the velocity and also the linear velocity as well as the angular velocity using this vector analytical method. Okay, kita ada dua cara kita we can kita gunakan apa? Tadi the first one is a lukisan graphical method ataupun you gunakan vector analytical method like this using loop equation and this is the example. Okay, this example. Okay, look at this one. All right, now if you look at this problem, okay, this will be the input link. This will be the point. We know that this is the velocity of the input is 15.7 meter per second. All right, and then you have to find the point. Dikata secara nilai ni x. Point x is the point of interest. Then you have to find the velocity of point x. Before that, dia kata soalan ni mungkin ada lagi sebelum tu cari positions of point x as well. Point x as well bila dia punya apa angle berubah instead of 130 kepada 150 for example. Ini adalah soalan-soalan. Tapi before that you have to do this position analysis. And then once you have done all the position analysis, then you can go to the next one to find the velocity. of the point of interest. For this case is point X. Right. And then you have to draw lukis. So we know that based on this should be 90 degree, and you lukiskan ni line-line yang line-line yang perpendicular to all of the link. Kan yang perpendicular mesti 90 darjah. You letak ni, that is called velocity line of action. Alright. We can find this. Kita nak cari nilai ni. Sebelum tu we have to know this point. Right. Let's say this is point A, let's say this is point B, let's say this is point C, this is point D, isn't it? This is point D. So we're going to find point, the velocity point here. We know that, okay, we know that the velocity is going to this way. So mungkin this one is also, this is the velocity point. Point apa? Velocity of point C. Kalau kita tengok, for this case, when the arms, the input arms rotate, okay, clockwise, counterclockwise direction. Saya freeze ke? Assalamualaikum.
Okey ada.
Okay, tapi saya punya video freezing. Okay, tak apa. Alright, so kalau kita tengok, it's going to counterclockwise direction. So point C pun is going to this way. Kan? So this should be 90 degree from this link. Mesti 90 degree from this link. Mesti perpendicular to this link. Jadi kita dah ada, we can draw. Okay, for this case, okay, you nampak ni. Let's say this is the origin. Origin is the one that connected to the to the point. The pivot point is pivoted here. Jadi kita letak dekat sini lah. Kita lukis kat sini. Lebih kurang macam ni. Macam ni. VB is going to this way. Okay, 15.7. This is 15.7. And then VC, kalau you tengok VB dengan VC ni tak sama kan? Nampak ni. Ni VC, this one VB. So kita dah ada VC and VB. Now, we can put this one. Nampak? This is VC related to B. So VC related to B, this one. So kita sambung semua. Kita close the loop ni. Kita sambung supaya dia close the loop lah. Close the loop for this kit. Then we can find VC and also VCB. For VC, we can just simply what? Simply measure. Okay, this is graphical solution. You just measure the length of the VC. So, kita measure ukur je lah panjang VC tersebut. Alright, now, kita dah ada VC, kita dah sambungkan ni, and we have this, kita nak cari VC dekat X. Right, dekat X ni, we're going to find the velocity of X. Point of interest for this case is Okay? Dah okay ke? Sorry ada masalah technical. We got technical problems just now. Okay, can you hear me now, class?
Boleh.
Boleh, okay. Kita sambung Jadi kita dah lukis ni, kita dah lukis yang ini. So the next one is we need to find the point of interest. Dengan kita sambungkan dengan point of line of action tadi. Kan for this case kita ada line of action yang ini, yang ini, yang ini, yang ini. Jadi kita nak pilih dua ni, dua ni. Okay, kita ada dua ni, jadi kita sambung lah. Kita sambung, kita nampak kita sambung. So bentuk dia macam ni. Yang ini. Jadi kita sambung satu, kita nampak sambung satu sini, sambung satu ni. So this is point of interest X. So now we can find the velocity dekat point ni. So Vx adalah 18.03 meter per second. Okay. Alright, so this is Vx. Okay, velocity point X. So velocity point X, let's say is somewhere, we don't know, kita tak tahu kat mana. So somewhere here. So we need to find the velocity of X here. So velocity of X here, macam mana kita dapatkan? Kita dah ada velocity line of action here. Kita ada dua ni kan. Kita sambungkan these two lines here. This line mesti perpendicular to the link. Right, dia perpendicular, mesti perpendicular 90 darjah to the link. So kita combine kan, put in the drawing here. We put in the diagram here. And then the intersections will be the velocity of point X. So you ukur panjang ni, berapa panjang ni? For this case, the length of that vectors is 18.03 meter per second. So kita dapat dah. Kita dah dapat cari nilai velocity pada point X. Alright, ataupun kita gunakan analytical solution, gunakan vector polygon macam ni. So kalau you suka, I'm not very good in this one. Saya pun tak suka, I don't prefer to do this one. So if you want to do this, you can look at this on how to solve the problem. So basically, the answer is quite similar. And the answer is 18.035 meter per second. Kalau kita guna lukisan 18.03 kan, kita lukis and then kita ukur the length. You just measure the length from the drawing, right, using graphical, using CAD software. Based on that, kita dapat 18.03. So based on the analytical solutions pun sama juga kan, kita from the vectors here, the answer is the same. So it's the same as the graphical solution. Alright. Okay, now ataupun we can also find it, okay, using circuit diagram. For example, using the slider crank velocity. Okay, so this one for slider crank velocity, kan kita dah belajar cari position. Right, we have learned how to find this position using the circuit diagram. Kita dapatkan minggu lepas gunakan circuit diagram, circuit 1, circuit 2 untuk 4 bar. And then kita ada offset and also inline for slider crank. It is also the same for this one, for velocity. Dengan syarat kita kena buat dulu position analysis to find the unknowns, angles and length. Right, to find the unknowns, yang unknowns, angle, the length. For example, last week kita dah belajar nak cari nilai R4. Right, the distance of the length from the reference point when the angle 2 is given. Right, sekiranya angle 2 diberi, let's say 60 degree. So berapakah kedudukan, the initial kedudukan of this point ataupun of this slider, right? You can find the length of R4. And based on that, remember, we can also find the theta 3, based on the position analysis we have done last week. So now for velocity, kita sambung. So we need to find the omega 3 So when we know the omega here, right? Omega is given ataupun velocity. The input velocity is given. Mesti diberilah. Kalau tak diberi macam mana kita? That's the reference. So either omega, okay, omega 2 ataupun dekat sini ataupun velocity B ataupun velocity 2 lah. The same point here, this point. Alright, then when we know the velocity, we can find omega 2. Ataupun when the omega 2 is given, we can just put it into the equation here. Okay, put it into the equation here, then we can find omega 3. But we can find the omega 3. Omega 3 might be this one. Okay, this one bergerak kan? So this one will be omega 3 lah. Ataupun macam tu. The other way. Kalau going this way, ini kalau kita push down here, this will be going to this way, isn't it? This will be going to this way. Push down is going to be this way. And then this is omega. Omega, it should be something like whether it could be the same as the input link. Alright, so basically you just put into the equation, boleh masukkan sahaja equation ini to find the omega 3. And then based on that, bila dah tahu omega 3, we can find V4. This is number 4, right? The slider is number 4. Then we can find the velocity of the slider using this equation. Dengan syarat kita mesti ada omega 3. When we know omega 3, just put into this equation. Omega 2 dah ada, put into this equation. R kita dah cari, R2 given, selalu dia given. And R3 is also given, R3 is also given. The length of the links are always given. Otherwise, you have to find it using trigonometry equation ataupun using sine or cosine law to find all the length of the link. Then when you know all the length of the link, then you can find the unknowns yang you tak tahulah. Okay, ataupun unknown soalan selalunya soalan yang diberi untuk mencari unknowns. The question given to find the unknown. Right, for this case, you just simply put dengan syarat kita punya drawing, the question must be similar to the diagram here, to the circuit diagram here. Mesti samalah. Otherwise, I remember last week kita pusingkan kan. We turn around, kita pusingkan. Okay, we turn around our diagram to make it similar to the slider crank diagram. So the circuit diagram ataupun circuit diagram yang pusing. Dia punya apa-apa? The fundamentals ataupun dia punya syarat dia, condition, the drawing, the diagram should be similar. Baru kita boleh put in the equation, given equation. Right, this is for the slider cranks velocity. For the 4 bar, okay, the next one is 4 bar. So 4 bar also similar, hampir sama. Dengan syarat kita kena buat juga analysis untuk cari all the unknowns as well as the unknowns angles as well the length. Then baru kita boleh gunakan this equation, this omega 3 and omega 4. So dah dapat omega 3 and omega 4, apa kita cari? Sebab kita nak cari nilai let's say this one kat sini. We can using these equations. So this is the main equation. We know that R omega sama dengan velocity is equal to R omega. Bila kita tahu setiap satu omega, right? Let's say V3 contoh V3 R omega 3 kan, R3 lah kan, V3 R3 multiplied by omega 3. So in this case kita dapat omega 3 and then we can find also omega 4. For this case, this is omega 2, this is omega 2, this is omega 3, so this is omega 4. All right, so we can find omega 3 and omega 4. But we can also find the linear velocity for point, let's say this one, point 1, A, B, C, let's say. So we can find VC R3, this one VC R3 kali dengan omega 3. Right, okay, that is how you find it. Okay, that is how you find it using the using the what? Using the circuit diagram. So for me, which one is easier? For me, this is quite easier. But the most important thing for this case, for this method, you have to what? To turn around to make sure your to make sure that your diagrams, right? Your diagram should be similar to the circuit diagram. Itu je. Dia punya condition, syarat dia adalah mesti sama. The circuit diagram should be similar to your diagram. And then baru you boleh gunakan all this, the equation given in the circuit diagram. Right. Okay, so we have done this one. Okay, going to the next one. The next will be the last, the position, the accelerations. This is also the optional. This is also the optionals. And this one is quite similar to what we have linked. Now, sama juga, the same. So as I said earlier, the most important is that you know the concept of the position analysis. Once you know the concept of the position analysis, then, all right, the next step for velocity as well as for accelerations will be easier. Akan lebih mudah lah. Okay, now kalau untuk what for acceleration, okay, when speed change. Jadi when the speed change, takkan kita bawa the same speed kan? Takkan kita drive the motor at 100 RPM all the way constantly. Sama saja, no. Kita akan the acceleration ataupun deceleration. Kita akan ada pecutan. Okay, for certain time kita ada acceleration, right? And also a certain time will be deceleration. So that is the panggil acceleration and deceleration lah. Okay, so dia ada hubung kait dengan force. Okay, force kalau using Newton law, okay, force is equal to mass multiplied by acceleration, right? And basically for acceleration could be, there are two types, sama juga the linear and angular, as similar to what we have discussed in velocity. Velocity also we have two, linear velocity as well as angular velocity, right? It is also the same for acceleration. There is linear acceleration as well as angular acceleration. So the main equation for accelerations is equal to 2 kali. Kita punya velocity is equal to, so velocity is equal to ds dt, isn't it? The change in distance over change in time, right? Kita buat apa? Kita pembezaan kan? Pembezaan sekali beza in terms the change is distant over the change in time. But for acceleration dia 2 kali. Kita 2 kali ada d2s dt as 2 kali kita buat pembezaan kan? Right. So this is the dynamic. I think you need to look at all this equation that you have learned before in dynamics, right? And so basically, if you look at this is the linear acceleration. Okay, the linear acceleration due to rotation. For accelerations, the difference between acceleration and velocity, kalau you tengok diagram, is quite the same. But ada tambah sedikit. For acceleration, we have tangential and radial, AT and AR. Right, so AT, AR. So for this case, so let's say this is AR. AR mesti dia it should be parallel to the radius. All right, for this case, it's the same as the link. The directions, the vectors should be similar to the link, right? For this case, this is AR, and then AT is tangential, ataupun it should be perpendicular to the link, right? So we have AT. For this case, AT, when we know this is the angular, this is angular acceleration, alpha, bagi alpha, I don't know what's this. Let's say alpha. Alpha is the acceleration, okay, acceleration, angular accelerations. So pecutan AT is equal to R. R is the length. So for this case, R is the length kali dengan dia punya angular acceleration. Alright, so that is AT. So AR, this is AR. AR is equal to R omega. Omega is the omega velocity. So angular velocity. So angular velocity kuasa 2. So for this case is angular velocity kuasa 2. Ataupun kita boleh juga put it kalau W is equal to kan R sama dengan W sorry V sama dengan R omega, so omega sama dengan V bagi R, so put it here V bahagi R, so it could be R V bahagi R kuasa 2, so R kuasa 2 kita matikan, tinggal lagi R ni mati, tinggal sini, tinggal lagi V kuasa 2 per R. So it could be like this. So just remember that for accelerations, kita ada in term of tangential as well as in term of radials. For tangential is equal to R kali dengan angular acceleration, ataupun for radials it should be R multiplied by omega. Omega is the velocity, angular velocity that we have done just now before this, and this kali kuasa 2. All right, so that is for linear acceleration. For Riolis acceleration like this, kita ada atas bawah kan, dia akan berubah ni. This one, it look like macam slider. So that will be also AT and AR is the same. And for AC, this is an ACB. AC in terms of in these directions is equal to like this. Okay, 2 kali dengan omega V kuasa R. Now, you can look at this example. So this is a straightforward example. Okay, let's say point P. Okay, this is point P is moving at 50 cm per second. So that is the velocity. So we know that given that the velocity P is 50 centimeter per second, at the point shown, what is the point shown? At this point, at the angle 30 degree, that is the instance, ataupun that is the initial conditions of these problems. The link start to slow down, then stop in 5 seconds. Okay, now look, you need to find the acceleration point P. We know the halaju, we know the speed, we know the velocity. We need to find the acceleration, and also we need to find the acceleration point. Okay, now, so we know that Vp, we can find omega. All right, V sama dengan RW. So, so the omega is equal to V bagi R. R is equal to, V is equal to 0.5 meter per second. We convert it into meter per second. And then dia punya the distance, the length is 25 centimeter, 0.25 meter. So for this case, we have omega. Omega is the angular velocity. Angular velocity for this case, for this rod, is 2 radian per second. All right. So we know that when we know the angular velocity, we can find the alpha. Here is the angular acceleration. Angular acceleration for this case, we know that from the conditions is 0 minus 2 radian per second, daripada kosong ke 2 radian per second. So bahagi dengan dia punya distance. Distance adalah in 5 seconds. They stopped. Okay, the link start to slow down, then stop in 5 seconds. So daripada kosong ke 2 radian per second, bahagi dengan bahagi dengan berapa lama? Berapa lama? Ada 5 saat. Okay, 5 saat dia akan stop. So kita ada 2 bahagi 5 adalah 0.4 radian per second square. So this is the angular pecutan. And this is the angular acceleration. Okay, now we know that using the equation yang kita ada A tangential as well as A radial. Okay, kalau tangential tadi apa? Kita punya R kali dengan alpha. R kali dengan A. Bukan this one. R kali dengan angular acceleration. Okay. R kita is 0.25 meter kali dengan angular acceleration. So accelerations for at point P, okay, ataupun for the link, so accelerations for the link, okay, tangentials is what? Minus 0.1 meter per second square. So for radials, so this is tangential, this is radial, this is radial, so this is tangential. So radial is R kali dengan V, V cos 2 bagi R, isn't it? V cos 2 bagi dengan R. APR sama dengan V cos 2 bagi dengan R. V cos 2 bagi dengan R. Ataupun, boleh tak guna ni? Kenapa guna ni? Kalau you tengok ni, 0.25. Ataupun R omega cos 2. Boleh juga. R omega cos 2. Omega kita adalah 2 radians. Jadi 2 radians per second cos 2. So dapatlah 0.25 multiply by 2 radians, kita dapat 1 meter per second square. So this is the answer. Okay, nampak? So this is all the answer. Alright, so calculate the accelerations of point P. Okay, that is the answer in terms of for this case. Then, okay, then you boleh gunakan. Sorry, the answer is 1. The answer is 1 meter per second square. So in terms of tangential and radial, so kita kena cari dia punya apa? Dia punya this one. Panggil apa ni? Resultant. Resultant. So we have tangentials, we have radials. Tangential 0.1, radial 1. This is radial, this is tangential. Okay, square root kan? Square kan? Lepas tu kita square root kan. So the answer is 1.1004 for the accelerations at point P ataupun the link, the highlight ataupun pecutan link tersebut adalah sebanyak 1.005 meter per second cos 2. So that is the acceleration. Ataupun you nak lukis ni pun boleh. You gunakan graphical methods. You lukis and then you just measure the length. The length is equal to 1.005 meter per second cos 2. Okay. Alright. Kalau gunakan vector polygons, you can do this. You can look at this. Okay, boleh tengok contoh ni. Okay, contoh ni. This is different one. Contoh for the for 4-bar mechanism. Alright. I'm not very good this one, so that's why I don't like this one. Saya tak suka vectors. So that's why, because we have different type of methods. So meaning that you can choose another method if you want. If you like this one, you can do this one. Kalau nak guna method ni pun tak apa, tak ada masalah. Meaning that you have different options. Right? So we have different types of methods, so we can just choose which one is good, is better for you. All right. For me, you can try this at home if you want to. Right. At least as long as you know that there is a method of vectors using vectors polygons. Ada cara gunakan vectors polygons, tapi saya tak, for me saya tak gemas kira, saya tak berapa mahir. I'm not very good in these vectors. Okay, so you boleh gunakan, you can do this if you want to. If you don't want to, you can choose another methods. Okay. Contoh ni, you can try this exercise. Okay, and also this exercise, and the last one, as I said, we can also use analytical solution using the circuit diagrams. Yang ni yang saya rasa this one a little bit ataupun this one is easier compared to the others methods. Lebih mudah. Dengan syarat kamu kena faham konsep, as I said, concept of the position analysis, the one that we did last week. Alright, kita kena pusingkan the drawing, the diagram should be similar to the circuit diagram. Okay, and then based on that we can find all the, let's say, okay, start from positions. If we have the problems, all right, and then the problem should be similar to the circuit diagram. So we have 4-bar circuit, circuit 1, circuit 2, and also we have the slider crank, all right, for offset and inline diagram. So based on that we can find this, the for example, for the positions theta 3, all right, and then based on that we can also find the velocity, angular velocity for the link, and also the linear velocity for the slider. Right, this is for the slider crank, slider crank. And then kita juga boleh cari sebenarnya adalah we can find the accelerations, the angular accelerations of the link tree, as well as the angular acceleration for the sliders, right? So you can try this, you can look at this. The equation is quite long, but if you have all these things, if you have all this, you dah ada theta 3, you ada theta 2, let's say this one theta 2. Theta 2 is the initial angle that will be given. Theta 2 will be given, always will be given, and R2 all given. R semua dah tahu, you have to find all these things. You just put into the equation. Dengan syarat dia punya diagram should be similar to the circuit diagram. Okay, and then baru you can solve all this from the equation. Now, for 4-bar, this is 4-bar mechanisms, so we can find theta 2, theta 3, theta 3 and theta 4, right? But for theta 2 is given, so we can find theta 3 and theta 4 for circuit 1 and circuit 2. Circuit 1, circuit 2 ada slightly different. Circuit 1 is something like macam ni kan, yang biasa ni kita jumpa circuit 1 lah. Okay kan? Kalau circuit 2, if I'm not mistaken, dia macam ni. Dia macam ni. The line sikit. So you kena pastikan your problems fit circuit 1 or circuit 2. Sama circuit 1 ataupun circuit 2. And based on that, we can find omega 3 dan juga omega 4. And based on that, we can find V4 kan. V4 could be R omega 4, right? We can also use these equations. Don't forget this equation. And then for acceleration, sama juga, these are all the equations. These are all the equations for the acceleration. Dengan syarat you have to understand the concept. Meaning that you cannot leave the other method as well. Kamu juga kena tinggalkan keseluruhan method, as long as first thing that you have to draw it. Okay, you draw, everything should be drawn. So mesti dilukis, mesti you have to, what I call it, you have the problems, right? You have the problems from the question. For example, let's say we have the problems of what, of lori sampah, lori yang angkat tanah tu kan, contoh lori yang angkat tanah. Ingat tak minggu lepas kita ada buat satu example lori angkat tanah tu. So bila dia punya bed, bed tu dia punya yang bawa tanah tu kan, diangkat sebanyak 60 darjah contoh kan. Alright, so from that diagram, from that figure, you have to transfer, you have to draw the kinematic diagram, right, and also the free body diagrams. Daripada situ baru you boleh construct the solution, baru you boleh construct, you lukis, you boleh imagine ataupun you boleh dah plan kan apakah solution yang that you have to do, right? Sepatutnya is the same lah, sama lah, ataupun sepatutnya it should be in sequence. Selalunya kalau you tengok if you refer to the previous questions, final examination question, so basically the question is in sequence. Selalunya memudahkan kamu untuk solve problems. Kita selalu cari nilai position dulu, position of the point of interest, Sebelum tu kena cari mobility dulu. Let's say find mobility. Supaya you kena draw. To find the mobility, you have to draw the kinematic diagram, isn't it? Daripada drawing kinematic diagram, lepas tu cari mobility, lepas tu cari position. Macam mana cari position, dan your drawing should be the same as the circuit drawing. Kalau tidak, tak boleh nak buat lah. Daripada situ baru construct the next one, boleh cari velocity as well as acceleration using all this analytical solution. Right, don't forget, bukan bermaksud you kena tinggalkan yang apa ni graphical. You can also do it using graphicals, using CAD software if you want to. Right. Saya maksudnya saya tak focus on the graphicals, meaning that you don't have to do it using graphical. You can do it using graphicals if you want to. You can try at home if you want. You look at several examples in this class or in the textbook, and then you can compare the result. Okay, you cuba buat gunakan CAD software using graphical method. Then when you have the answers, you just compare dengan analytical solutions using circuit diagrams. The answer should be similar. Right. So saya lebih fokus kepada analytical solution rather to graphical solution. Kalau mungkin lecturer lain, kalau you tanya kawan-kawan lain dalam group lain, mungkin tak sabsi Dr. Samsul Anwar, dia prefer gunakan graphical solution sebab dia suka lukis. Saya tak suka lukis. Dan saya I would prefer doing these problems using analytical solution. Right, I think that's all for today. Thank you very much for your attention and also attendance. Do you have any question before we stop? So I think basically, okay, this is the example. You can try this at home. So basically, kalau kita gunakan graphical solutions, you have to identify all these things in terms of tangential as well as the radials. Okay, based on that, you can just draw it, lukis, kan? Draw all these things. Lepas tu baru boleh carilah, just measure the length. Alright, so measure all the length here, all the vectors, right? The length of the vector, then we can find we can find the answers. Okay, this is vector solution. Kalau vector solution ni, as I said, I'm not very good this one, but you can try. You can look at this at home, and you can also discuss with your friends to find the answer. And the answer should be similar to others' methods. All right. Okay, that's it. So for this case, if you look at these problems, you have the solutions from the graphical solution and also vector solution, and you can try one more method using the diagrams, using the a circuit diagram. Okay, using circuit diagram, then make sure that the diagram should be similar to the circuit diagram. Saya rasa for this case not too difficult, tak berapa susah, isn't it? This one is not so difficult. The question here is not too difficult, as long as if you look at this is using slider crank. This slider crank mechanism, then you can just put draw the diagram, and your diagram should be similar to the slider crank. Okay, pusingkan supaya similar to the slider crank, and based on that you can just put into these equations given here, and you can find all the velocity as well as accelerations for the questions. But before that, don't forget to do the position analysis first. Try to find the unknown vectors or unknowns, length as well as positions, and also the theta, unknown thetas. Right, I think that's all for today. If you want to know more about this topic, you can go to the main reference from Miska textbook. You can find it in Shopee ataupun dekat Lazada ataupun online store. If you want to buy this textbook, this is the main textbook for linkage and mechanism, right? Machines and mechanism. This one I think quite long. I don't have this copy. I have the copies very long time ago. Tapi mana tak kopi saya dah hilang dah. So I don't think we have online copy or soft copy for this ones. Kalau you Google, you jumpa, bolehlah share dengan saya. Or you can buy it. Okay, untuk lebih faham topik-topik yang related to mechanism. For example, for in this topic, the main reference for certain topic from this textbook, contohnya linkage mechanisms is I think most of the linkage mechanisms, lecture notes, everything is taken from this textbook. All right, for the balancing, also from this textbook. Right, for the balancing, also from this textbook, and also for the gyroscope, if I'm not mistaken, is also from this textbook. Right, the rest basically from Shigley. Yang lain tu daripada Shigley. So that we have two main reference for this subject, for this course. So kita ada Shigley as well as kita ada Miska textbook. Alright, sebenarnya kan if you kalau if you want to know before that, before I think since 2000, I'm not sure, 2006, sorry, 2012 or 2014, something like that. Before that, we have two subjects. Right? We have two subjects. We have mechanic machines. Mechanic of machines. We have that subject, and also we have mechanical design. We have two separate subjects. And since 2014, okay, kita we review the curriculum, then we have to add another one more subject in your program. Then we have to add these two subject, combine these two subject become one subject. Jadi kita combine dua subjek jadi satu mechanical design. Kita tambah lagi beberapa elements in machine, mechanic of machines. Okay, mechanic of machines. Subjek mechanic machine tu dimasukkan dalam subjek mechanical design tu sebab kita ada two separate main references. Satu is Shigley, satu lagi adalah this one's Miska. Sebab Shigley purely mechanical design. If you refer to Shigley, you don't find this one. Ada tapi dia tak related to macam linkage mechanism. Linkage mechanism. So I didn't find the linkage mechanism in this textbook in Shigley, right? So that's why basically we have two different types of textbook. Okay. So if you want to buy it, you can buy it. Okay, from Shopee kalau ada, ataupun from online store. If it is available to be bought. All right, I think that's all for today. Thank you very much for your attention and also attendance. All right, don't forget to record your attendance in Newland. So we have one more final class that will be on this Thursday. Okay, on Thursday I will wrap up. I will do I always call it as a surgery sessions pembedahan. Session pembedahan. So during that time, I will briefly discuss, or I will briefly explain or summarize all the chapters that we have learned in this semester. Semua chapters, all the topics we have covered in this chapter that will be explained in short, brief explanations during that session, during that surgery session. Saya akan buat summarize sikit lah, supaya you got the ideas what you have learned in this subject for this mechanical design. For this mechanical design, saya akan buat summary. But for that, on top of that, saya akan explain ataupun sedikit bincang berkenaan dengan, saya akan buat relate dengan final examination questions. Saya akan relate sedikit dengan exam question nanti. kita akan discuss lah sama-sama. Alright? Boleh macam tu? Alright. So I try to what's that? To finish marking your um, your quiz tu. Okay, basically I think saya dah go through your quiz tu, jawapan lebih kurang sama je kan, tak tahulah. Saya tengok macam sama je. Okay, fine, saya akan tengok, saya akan marking dan saya akan bagi markah in this week. So basically if you refer to your SMP, okay, your marks from the SMP, that total mark is 25 from SMP. Okay, 25. Add another 5. Mungkin saya tak masuk lagi. 5 will be your quiz too. And then ini sahaja yang saya akan masukkan dalam minggu ni lah. Saya akan masukkan lagi 5 markah. And then you have 10 more marks for your assignment. Don't forget to submit your assignment on this coming Friday. Jangan lupa submit assignment on coming Friday. Only the representative is allowed to is required to submit the report. And don't forget to write the file, the report file, based ataupun using your group number. And group number 1, contoh group number 1, section 9. Saya nak tahu juga section tu sebab nanti submission tu akan campur dengan section 9, 10, 11 kan. So please write down, put the names on the files as the group 1 section 9, so that easier for me to check it. Right. And then what else we have done? Okay, so kita all together the coursework mark is 40, so you have another 60 for final examination questions. So based on the coursework mark, mostly I think around, kebanyakan ataupun average dalam 20 lebih lah. Setakat ni kalau per 25 dalam 20 macam tu. So kalau tambah lagi 5 mungkin dalam 25 per 40. That's average. Ada yang 30 lebih, that's very good. 34, 35, 36, 37 per 40. I will expect that your mark should be around 30 plus, 30 plus macam itulah. Sebab kalau tambah assignment let's say dapat average 7 markah. So let's say your punya quiz semua ni dapat dalam 20. Kalau 20 plus 7, 27. So that's why as I said the average will be 25 macam itulah, 25 per 40. And ada juga yang akan dapat 30 ke atas lah, 30 ke atas based on your test as well as the quiz 1 and also quiz 2. Okay, plus dengan assignment. So don't forget to submit the assignment. Assignment pun tak nak panjang sangat assignment, sebab I don't have to explain the detail on the assignments, on the way how you write assignments, because you are not in year 3. Year 3 ni sepatutnya assignment tu dah tak ada masalah. Mesti kena ada introduction sikit. Introduction is very important because introduction to introduce your problems. Yeah, you have to put the problem statements, kan problem apa, then you have to the objective of the your assignment. Objektifnya apa, nak buat apa, nak buat analisis apa, dekat mana yang problemnya, right? So you have to explain all these things, right? That is part of introduction. Itu dah sebahagian daripada introduction. And the second part is the analysis lah. So I want to see the analysis, how you do the analysis, how you find all the for example the speed, input speed. You know the input speed, you can find the output speed, as well as you can find the forces analysis right in the gearbox system, right? I think itu the way how you prepare the report. You can do your own. So you can do yourself because you have learned this before. And in fact, you are now in third year student, you are mature student, so I don't have to explain it again many times. All right, I think that's all for today. Okay, any more questions before we start? Any more questions? Ada soalan tak? Alistair? Alistair, do you want to ask me questions? Iskandar, ada soalan tak Iskandar? Iskandar kan juru cakap kumpulan berapa hari tu? You can talk very well. You can explain very well. So would you like to ask me questions today? Dia dah tidur dah ni, Daniel. Daniel Iskandar. Daniel? Daniel? You don't want to speak to me? Haris Najmi.
Ya, doktor.
Terus left. Haris.
Ya.
Okay. Faham ke?
Boleh lah, doktor. InsyaAllah.
Boleh lah. Tak boleh, kena boleh. Tak boleh, boleh lah. Boleh.
Boleh.
Okay, okay. Haziq? Ni nama Haris dengan Haziq ni sama dekat-dekat. Haziq atau Haziq. Nama dia pun dekat-dekat sebelah ni. Haziq.
Ya, saya doktor.
Okay ke Haziq?
Okey ke?
Satu rumah dengan Haris ke?
Tak.
Lain. Lain rumah. Okay, okay, okay. So kita dah habis dah tau. So we have done this. We have done. Everything is done. It's completed in this subject. Semua kita dah habis 6 chapters. So kalau nak tanya apa-apa, you can ask me questions. Firdaus. Akif. Saya imagine tak, I just imagine in my mind that you are in the room, you are in your own house, sama-sama. Kayak ada beberapa dalam rumah tu ada beberapa bilik, and then dalam bilik tu mungkin ada meja study kan, betul tak? Ataupun you akan berkumpul dekat the main hall. Kalau sama all the class mungkin main hall, you ada meja kecil ke ataupun macam tu. I just imagine macam tu kan, sebab I was student dulu kan, sama je. And then it is about, macam mana nak cakap kan, during the examinations, it is about you all ni apa, you buat discussion kan dekat main hall. Just imagine this is your main hall. Okay, so everything is berkumpul, okay, in the main hall. Okay, when you have the questions, okay, you grow up, soalan apa ni? Sama tak? I can do this question, you can do this question, and then you can collect all, and you just write it down without semak balik kan. Itu mungkin it might be like that. Mungkin macam tu lah. Mungkin macam tu. I'm not accused. Saya tak adalah, saya tak tuduh lah macam tu. Cumanya I was thinking like that. Saya nampak macam tu. Tapi that's why again you have to do your own. You have to do your own during the examinations. Because why? Because jawapan dia not correct. You just put in your mind that your friend's answer is not exactly right. Bukannya tepat. So that's why you have to do your own. You have to trust your answer. So that's why saya suka. But I want to teach students to be what you call it, to confidence your answers. When you have the answers, then that is my answer. That should be correct. Itu sepatutnya you buat, that's sepatutnya correct, because you are going to be engineer after this. You have to do your own. You have to do yourself, right? And then okay, based on that result you get, you have to confidence that result. So that's why kalau you perasan saya takkan bagi soal jawapan. We do the same. Kita buat, we do the exercise in the class together. Tapi saya akan leave it to you your answer. You have to get final answer. Kita buat sama-sama, tapi saya jarang ada supply the final answer. For me, you have to do your own. You have to do yourself. Right? Bila dah buat, make sense tak jawapan ni betul ke tak, confident. You have to confidence with your answer. You have to trust it. And also if you want to do it with your friends, buat sama-sama dengan kawan, and also you have to discuss together, and you have to what you call it, to confident. You guys, everybody has to what to not contribute to confidence, to trust the answer. Alright, so that's why jawapan tu sepatutnya macam mana for your final examination. So that's why if you do discussion, no, I mean if you copy from your friends, then your friends answers is not exactly correct. Okay, macam saya pernah jumpa skrip jawapan yang sama, exactly the same, even the point, the dot, kan, titik, the first student comma, okay, second student pun buat comma, padahal tak perlu pun comma tu kan. So exactly the same, and the answer is totally wrong. So macam mana tu? Takkan boleh. Kalau wrong, takkan sama kan? It cannot be the same, isn't it? Cannot be the same. So be careful on your answers, eh? Alright. Sufi Aiman, tadi saya panggil tak menyahut. Sufi, are you there? Ke tak ada mic? Ke macam mana? So, okay, still not available. Sufi. Yong Chi Yong. Dah hilang. Okay, ada dekat chat kot.
Yes, Doctor.
Siapa tu?
Yong
Yong.
Chi Yong.
Ada pun Yong eh. Yong satu rumah dengan siapa?
Satu rumah dengan Alistair.
Alistair. Alistair lagi?
Aziz.
Haziq. Okay, alright, Haziq. Zul Helmi. Zul Helmi bukan. Satu rumah dengan Zul Helmi bukan?
Doktor.
Ada. Sihat lah Zul.
Sihat.
Daniel, kenapa keluar masuk internet problem eh?
Oh, dia punya bateri habis tadi.
Bateri apa? Bateri handphone?
Bateri laptop.
Oh, bateri laptop. Tak charge ke?
Dia ingat buka pula tadi.
Oh, okay. Alright. Okay, so jangan lupa kita dah habis. So your responsibility, tanggungjawab kamu to submit a report. Okay, jangan lupa submit the report on this Friday. Dan this Friday. Okay, ada soalan ke sebelum kita tentang assignment ke, nak tanya ke tentang apa? So that's why assignment tu, as I said, mesti kena ada introductions, and then your discussion. Maksudnya your analysis come with discussions. Kan bila dia buat analysis, as I said just now, result to make sense ke, you have to explain the results. Kan figure, you have to explain the figure. When you have the figure, you have to explain it. You don't simply put the figure without any explanation. Letak gambar tapi tak ada explanation. Saya kadang, kenapa gambar ni kan? Gambar ni, apa dia gambar ni? Kadang kita faham gambar tapi tak explain. At least you have to explain it in one paragraph. Very short paragraph. Explain it. Cerita sedikit. Gambar ni adalah berkenaan apa-apa. Free body diagram ni adalah berkenaan dengan apa-apa. Okay, and then blah 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 blah. Okay. But you have to explain your answer. You cannot simply just leave the final answer VB sama dengan 10 meter per second. That's it. You have to explain it. Okay, based on the analysis done, blah blah blah, using circuit, blah 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 blah, and then VB is equal to 10 meter per second. You're going to figure out. Cerita explain it. You have to explain it. This is how you write the report. When you become engineer later on, you have to write it. You have to put everything in the report. Kan? Jadi kena letak dalam report. You cannot just simply report it verbally. You have to put it in the report written, ditulis. Kan? Okay. So, and then when you have all the discussions, and it should be closed. You say it should be closed in conclusion. Ada satu subchapter kecil, conclusion. Dalam conclusion tu, you have to conclude everything. What you have learned, what you have done for your assignment, and then what you got, okay, and then mungkin ada juga yang not not achieve your you want to find it but you cannot find it due to limitation. Mungkin you tak dapat cari due to some limitation, but you have to explain it. What is the limitation? And then also you can put the cadangan, the cadangan or the suggestion for the next one. Ataupun cadangan saya, kita boleh cari ni, mungkin kita kena tambah ni, bla 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 bla. So that's how you do the report. Okay, kita nak tengok solution. You have the problem, you have the solutions, and you have the suggestion. Okay, problem, solution, suggestion. All right, so you have to explain it. And then as I said in the introduction, you have the objective. Objective awak cari apa? Okay, contoh nak design satu gearbox. Gearbox ni digunakan untuk kereta ni dan kita akan we need to find the gearbox, the system. So daripada system ni we can design the gear, okay, the gear, and then based on the your new design kan, you propose the new design ataupun gear yang mungkin gear yang berbeza ke, arrangement and all those things, and then based on that apa yang you dapat, so that you can compare to the existing one, and you can suggest ataupun okay, so when you have the objective, the conclusion, adakah objektif awak tercapai? Contoh tercapai kan objektif saya untuk pergi sekolah, pergi kelas hari ni. Saya dah nikat pagi ni saya akan pergi ke kelas, saya masuk kelas kan. And then tiba-tiba saya tak dapat masuk kelas. So objektif tercapai tak tercapai kan lah, sebab kita tak dapat masuk kelas kan. So sama juga projek macam juga, you set 2 atau 3 objektif. So objektif 2-3 objektif tu tercapai or not. Kalau tercapai, then you have to explain it. You have to put it in the conclusion. All the objectives are achieved, kan? Ataupun only 2 objectives are achieved, okay, and then 1 objective not achieved due to certain limitations. What are the limitations? You can put in the conclusion. And bila ada limitation, you can propose ataupun you can give some suggestion. Alright, I think that's all. Thank you very much for your attention and attendance. See you again next meeting, next session. That will be on Thursday. I end the session. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. See you again. Bye.
Terima kasih, Doktor.
Sama. You all senyap je dah pukul 11 dah.